What if we could mine a planet made entirely of diamonds? What if I told you that planet actually exists and scientists have no idea how it is still there? This is Science Crumbs, where we make the universe make sense. Astronomers didn't just guess there is a diamond planet out there. They caught it red-handed, not once but twice, using two totally different methods. First, a team led by Michael Jeng was staring at a dead star called J2322-2650. This is not just any star. It is what remains after a star explodes and collapses, squeezing all that mass into something smaller than a city, but heavier than our sun. It spins very rapidly, blasting out radio waves like a cosmic lighthouse. Here's the wild part. Every 7.9 hours, those radio flashes arrive just a tiny bit late. Not much, just milliseconds. But that is like noticing a fly walking past a lighthouse from 10 miles away, in the dark. That tiny wobble meant something heavy was tugging on the dead star over and over, like clockwork. Then the James Webb Space Telescope took a look. It watched that same system in infrared, the kind of light our eyes cannot see but heat cameras can. Every 7.9 hours, the telescope saw a tiny dip in brightness. The timing matched the radio signal exactly. Two totally different instruments, two matching signals, both pointing to the same conclusion: something big is circling that dead star. You might want to pause here, because this is not just a rumor or a one-off blip. The planet is there. The evidence lines up like a perfect crime scene, radio waves and infrared light both pointing to the same invisible culprit. And nobody saw what happened next coming. A planet the size of Jupiter, with a year that lasts just 7.9 hours. This is no ordinary world. It circles a neutron star, a remnant left behind after a massive star explodes. All that is left is a core, crushed down to a sphere about 12 kilometers across, smaller than most cities, yet heavier than our sun. Imagine a teaspoon of this star's matter weighing millions of tons, more than every car in New York City combined. The planet itself is huge, matching Jupiter in width, but its orbit is a blur. Mercury, the speedster of our solar system, takes 88 days to complete a lap around the sun. This planet does it in less than 8 hours, racing so close to its star that the gap between them is just 2% of the distance from Earth to the sun. If you could stand on its surface, the neutron star would dominate the sky, spinning rapidly and sending out pulses of radio waves. Astronomers discovered this planet by tracking tiny delays in those radio pulses, each one nudged by the planet's gravitational pull as it whips past. The scale here is almost impossible to grasp. A city-sized star, a Jupiter-sized planet, and an orbit so tight and fast, it defies everyday experience. The environment is extreme, shaped by gravity and speed, setting the stage for forces that will soon push this planet to its limits. This planet does not just orbit close to its dead star. It is being squeezed, pulled, and twisted into a shape that barely counts as round. Gravity here is not gentle. It is more like an invisible wrestler, grabbing the planet and stretching it out so it ends up looking less like a ball and more like a lemon. Imagine a stress ball you squeeze in your fist. That is PSR J2322-2650b, caught between the crushing pull of its tiny, super heavy star and its own stubborn bulk. The planet is not spinning freely either. It is locked in place, always showing the same face to the neutron star, like the moon does with Earth, but way more intense. The forces at work are wild. On one side, gravity from the neutron star yanks at the planet's surface, stretching it outwards. On the other, the planet's own gravity tries to pull everything back in. The result is a permanent tug of war, leaving the whole world squashed and off balance. If you could float above it, you would see a giant lemon spinning through space, always pointing its narrow end at the dead star. But here's where it gets really weird. All that squeezing and stretching is not just for show. It is setting up pressures inside the planet that are off the charts. The outer layers get tugged and flexed over and over, while deeper down, the pressure climbs to levels you would never find on Earth. This is the kind of stress that can turn ordinary carbon into something extraordinary. The planet's shape is not just a cosmic joke, it is the first clue that the chemistry inside is about to go off the rails. The air on this planet isn't just thick, it's loaded with carbon, the same stuff in pencil lead and barbecue charcoal. But up there, it's not floating around as smoke. The James Webb Space Telescope picked up the fingerprint of carbon soot, a kind of cosmic smog hanging in the planet's haze. That's wild enough, but what happens next is straight out of a science fiction comic. As this soot drifts down, the pressure climbs to levels that make Earth's deepest ocean trenches look like a kiddie pool. Here's where things get mind-bending. Lab scientists on Earth have squashed carbon using tools called diamond anvil cells, basically machines that squeeze tiny samples between two diamonds until they hit pressures millions of times higher than your car tire. When they do this, ordinary black carbon flips into a diamond lattice. It's not magic, it's just what carbon does when you squeeze it hard enough and heat it up. And on this planet, there's way more pressure than any lab can manage. This sounds like sci-fi, it's not. It's just chemistry under pressure. Space has a lot of pressure. So while the top of the planet is smoggy and dark deep down, carbon atoms are packed so tightly they snap into diamond. Scientists even have proof. Shock experiments in labs show carbon turning into tiny diamonds in a flash. If you could take a cross-section of this world, you'd see soot at the top, diamond rain in the middle, and a solid diamond core buried deep inside. But here's where it gets really weird. This next part is the bit scientists can't explain. By every rule in the astronomy playbook, this planet should have been toast ages ago. Imagine parking a beach ball right next to a jet engine and expecting it to last for billions of years. That's PSR J2322-2650b, sitting just a hair away from a neutron star that spits out a hurricane of particles and radiation. The numbers are wild. Every second, the planet is blasted by a wind carrying about 10 billion units of energy for every square centimeter. That's like standing in front of a blowtorch the size of a continent, non-stop, forever. Early computer models said planets this close to a pulsar would get stripped down to nothing in a flash. Hydrogen and lighter gases should have been blasted off into space in just a few million years, leaving behind a bare, scorched rock. But the diamond planet isn't just hanging on, it's still got its weird carbon-rich atmosphere, and it's not shrinking away. The math says it should be gone, but the universe says otherwise. Scientists have thrown every idea at this puzzle. Maybe the planet's carbon-heavy skin acts like armor, making it tougher than any world we've seen. Or maybe it has a magnetic field, a kind of invisible shield, blocking some of the worst blasts from the neutron star. The truth is, nobody knows for sure. There's a gap between what the models predict and what's actually out there, and it's driving astronomers up the wall. Wait, it actually gets worse. If this planet can survive in a place where nothing should, what else might be out there, hiding in plain sight? And if you could somehow reach this diamond world, what would it take to chip even a tiny piece off for yourself? Picture a planet with enough diamond inside to make every ring, necklace, and drill bit on Earth look like pocket change. Scientists estimate that up to 15% of this world's mass could be solid carbon, most of it packed into diamond deep below the soot and haze. That's more diamond than all the mines on Earth, multiplied by 1,000,000, then multiplied again. You can almost hear the cartoon cash registers ringing. If anyone could get their hands on even a chunk of this planet, the diamond market back home would crash overnight. Diamonds would go from rare to about as special as gravel. Forget engagement rings, people would be paving their driveways with the stuff. And it wouldn't just be about jewelry. A mountain of pure carbon could change how we build, cut, and even power things, since diamond is one of the strongest and best heat-conducting materials around. But here's where it gets really weird. The closest rocket ever launched by humans would take tens of thousands of years to reach this planet. Even if you could somehow survive the trip, you would hit a wall of deadly radiation from the neutron star before you ever saw a single sparkle. No amount of spacesuit or shielding would keep you safe. Mining gear would fry before it even landed. So the diamonds are safe, for now. Right now, there's a planet out there made of diamond, spinning around a dead star smaller than a city, but heavier than our sun. Finding it was like spotting a fly walking past a lighthouse from 10 miles away in the dark. The universe hides weirder treasures than diamonds. What will we notice next? Let me know what you think below.